Hi there, welcome back. Well, it's time for the RF alignment, and as you can see, that involves quite a few bands and of course quite a lot of paperwork. And as I've said before, I'm thankful for this paperwork because it does make things a lot easier. So what exactly is it we want to do? Well, what we're doing when we do an RF alignment is actually fairly simple to explain anyway, the concept. But it gets a bit more complicated when you look at the schematic and you figure out exactly what it is they want you to do. If we start at the long wave, which is there, I've selected long wave, and let's assume I tune to a station on 200 kilohertz over there. If my front end is properly aligned, in other words, if my RF section is properly aligned, the station at 200 megahertz will come through exactly where the dial is pointing. I have tuned to 200 and the station is on 200 faithfully as I expect it to be. Now, if I'm receiving a signal that's on 200 kilohertz, that's going to be accurate. I mean, the transmitter is not going to change its frequency. What can change is that I might be picking it up, say, there, or there. Now that doesn't mean that the station has changed its frequency. It means that my front end is not properly tuned, not properly aligned. I want it to be picked up there because that's the frequency that they tell me the station is transmitting at. So we have a situation here where whatever we pick up at the front is mixing with the oscillator frequency, and it's coming through on the IF frequency. Now, what I did previously was I aligned the IF. In other words, I adjusted the tuned circuits on the IF block so that the intermediate frequency, which results from the mixing of the oscillator frequency and the front end frequency, that is the IF frequency. That is effectively a carrier at a predictable set frequency, the IF frequency, and it has on it the audio information that I want to decode. In other words, the radio station I want to hear at the end. So, as long as my IF stage is properly aligned, and part of this radio has one IF, 460 kilohertz, and the other part actually has two IFs. First it comes down to 2 megahertz and then down to 460 kilohertz. As long as I've got that properly aligned, then when I tune to a station of a known frequency like 200 kilohertz on long wave, I should get that station coming out at the back end. So if we look at the schematic, it becomes pretty clear what it is we're going to align. And it also explains some of the alignment instructions that we get on here. If we look at this instruction here, it tells us this is to align the front end. It tells us that for long wave, for example, we have to adjust it at 160 kilohertz and then adjust it at 370 kilohertz, and there's another adjustment at 240 kilohertz. Now what does that mean? Well, what it's telling us to do is to set the dial to 160 kilohertz, send a 160 kilohertz signal with a tone modulated on it, and we should be able to pick that up exactly at 160 on the dial. And if we don't, we need to adjust various things. Now, at the low end of the dial, at 160 kilohertz, there's not one, not two, not three, but actually 4 adjustments we need to make. This one is the oscillator. It says oscillator. This one says Zwissenkreis, I think that is. This one says Vorkreis, and this one says Ferrite-Antenne-Kreis. And then it gives us a whole lot of microvolt values and dB values. Well, what they're telling us to do here is they're actually telling us what sensitivity you're supposed to get. Now, the equipment I have is not accurate to the point where I can bother about that. So I'm going to ignore the actual sensitivities they tell you to check here, and I'm going to limit myself to adjusting for a maximum audio signal coming through the radio at this point with these adjustments. But before I go into all this, I'm going to explain, using the long wave as an example, on the schematic what these circuits mean, what these adjustments mean. They all say maximum, adjust for maximum. So maximum means I need to adjust them to get the maximum tone. I'm putting a modulated tone on there. I'm using a tone really to modulate. They say 400 Hertz, it doesn't matter. You can use 600 as long as it's an audible tone. But that tone I can hear. More importantly, I can measure it with an AC voltmeter at the speaker terminals. I don't have to rely on my hearing to determine that it's at its peak. I can actually look at the AC voltmeter, and for that purpose I use the Nordmende EM336, which is great because it's an analog meter and you look at the pointer. You don't have to look at numbers jumping around on a digital multimeter. You look at the pointer and it's nice and easy to determine where it's peaked. Just as a challenge, and this is learning from Mr. Carlson's lab, not that I'm anywhere near where he is in terms of expertise, I've explained that I have to feed a signal at these frequencies with a modulated tone on there to adjust the RF alignment of the front ends. However, my signal generator has a maximum limit of 20 megahertz, and I have various points here that require more than that. On shortwave 9, there's a 23 megahertz limit or point. On shortwave 10, there is a 24 megahertz point and a 29.5 megahertz point. Now, think about it, and this might actually hold you a bit longer on this video, or it might make you skip to the end or just laugh at it. How do I get 29.5 megahertz with a tone on it from a 20 megahertz signal generator? It's easier than you might think. You probably know the answer already, but we'll see that when I get to aligning this particular circuit. So let's have a look closely at what we're going to do. If we look at the schematic here, we've got a few sections that interest us at this stage. This is effectively the front end that we'll be tuning for those first 4 bands: long wave, medium wave, shortwave 1 and shortwave 2. The reason I say it's for the first 4 is because the shortwave 3 to 10 is actually on this upper section up here. And we can see how that works. We have the antenna coming in here, and you can select between the external antenna, which is the sockets at the back, or the whip antenna, or in the case of 2 of the bands, the ferrite antenna. Now here's a switch for the antenna, and your signal comes in, goes to here, and then it'll direct either to this section here or to the top section here with this switch over here. This is the shortwave 3 to 10, part of the shortwave 3 to 10 switch that goes up to the top. As you can see, you've got your antenna tuner here, which applies to those bands. We are only interested in this section for now, which is the 4 bands that you see on the top tuning dial. We will then do the shortwave 3 to 10 later. So let's have a look at this. We have this section here, which is the part that receives the antenna signal from here, or in the case of long wave and medium wave, if you don't select the external antenna, you actually receive it from the ferrite antenna. So if we look at long wave, for example, and we're going to focus only on long wave because the other bands are practically the same, you have this tuned circuit here, which is the front end, really the antenna coil, and that you see here 6 and 7, and that makes sense because that's the 6 and 7 that you see on the instructions for the top end of the band and the bottom end of the band. You also see this section here, which has a circuit for long wave as well, which has 1 and 2, 1 being a coil and 2 being a trimmer capacitor. And there's the medium wave, shortwave 1, shortwave 2. But then you've also got, related to each of them, in this case we're looking at long wave, we've got this one up here. And there's our point 3, which is a trimmer cap. There's our point 4, which is a coil. And there's our point 5, which is one that you adjust in the middle of the band at 240 kilohertz, if I'm not mistaken. So what have we got here? We've got an oscillator down here This oscillator allows you to adjust with the use of this capacitor. This is half of the tuning cap for those bands, and this tank circuit that's switched into that capacitor it allows to adjust at the one end the 160 kilohertz level or just below that, and at the top end you've got the tuning condenser, which allows you, when this is at the top end, to reach the 370 something kilohertz or slightly more. So this is the first adjustment, which is the oscillator. This is the front end, which is the antenna tuning. And then this is that intermediate stage that they talk about, which allows you to adjust the intermediate passband and optimizing it to receive and to send your signal through. Now this will already be effectively an IF frequency, because I believe, unless I'm mistaken, that I may be mistaken. I think this is the mixer here. Yeah, I think this is the mixer. So this is the one that mixes your front end with your oscillator frequency, and this is sort of, well, I guess the first IF amplifier, and this is your buffer to send that on to the rest of the IF stage of the radio. So we are going to adjust these points. When I talk about the oscillator, I'm talking about this one here, point 1 and point 2. When I talk about the front end, I'm talking about this here, point 6 and point 7. When I talk about the intermediate, I'm talking about point 3, point 4, and point 5. And then, of course, there's still two adjustments here on the ferrite antenna as well. Actually, those two there and those two there. One for medium wave, one for long wave. Now, I'm not going to explain all the other bands as well, because they're identical. When I say all the other bands, I mean medium wave, shortwave 1, and shortwave 2. They are effectively identical. So I'm going to go into great detail on the long wave and show you that on the radio itself and on the meter that's measuring the output. And then we'll just extrapolate and I'll show you the results of the adjustments on the other three bands. When we finish that, we'll move on to this baby over here, which I'm actually quite anxious to get to. Now, when we look at the instructions and they give us the points that we have to adjust to maximize, we will see numbers on there. And we have to look at this board. This is the RF board, and they show us the solder side, which is a bit of a problem, but we'll sort that soon. I'll tell you why it's a problem. It's actually in reverse. But if we look at the numbers, we're looking for 1 and 2, and there's 1, there's 2. We're looking at 3, 4, and 5, and we can see 3 here. We can't see 4 and 5, but we'll find that in a second. We're looking for 6 and 7. There's 6, there's 7. And we're looking for the ferrite antenna one, which is 8 and 9. Well, we can see 9 over here. We can't see 8. Now let's look for those. Some of those numbers we looked at are actually on here. And I'll show you. Here's one example. We were looking for number 4. And 4, there's 4, and if you follow that line, it's this guy over here. There's 5 that we have to tune as well, and if you look at 5 over there, that's the opposite end of 4. And then on the ferrite antenna, it gives us 8. We found 9 on the other board. We have to look for 8, and 8 will be this one here. It's that coil over there. There's 8. So we have to sort of jump around a bit, but that's what we need to do. The reason I said that this thing was backwards is because we are actually seeing the solder side, and when we're trying to identify or locate the components from the back of the board, or looking at the back of the radio, we're actually seeing the reverse of this. So what you need to do is you've got to imagine this looking at it from the front. So when you look at the back of the radio, the left is the right and the right is the left. The top and bottom stay the same. So you've got to be careful with that. Just take that into consideration. But we'll look at the back of the radio and I'll show you where the respective numbers are now. So point number 1 is that inductor, that coil over there. Point number 2 is that trimming capacitor over the top there. Point number 3 is that trimming capacitor on that side, the bottom one. Point number 4 is that guy over there. Point number 5 is that one over there. Number 6 is that guy over there. and number 7 is that trimming cap down there. Then we have to look for 8 and 9. 9 is that trimmer cap on the top there, the first one, and number 8 is one of the coils on the ferrite antenna, more specifically this one over here. So now with all the trimming points, all the adjustment points identified for the front end or the RF alignment of the long wave, I'm now going to set everything up and we'll do the adjustment. The signal generator is set to 160 kHz as instructed. There is a modulated signal, 30% modulation, a tone of 600 Hz, and it's AM modulation. And that is now on. The amplitude is not important. I've got it at about 10 millivolts RMS for now, but we'll adjust that as needed when we start listening to it on the radio. I've got the output from the signal generator just connected to this loop, just a piece of wire, and this is so that it can interact with the ferrite antenna first. The connection to the actual external antenna, you can also make it through that, but I'm going to adjust the ferrite antenna, so I'll leave it on there for now. And the radio is now ready to receive. At the moment I've got it connected to the speaker, and the reason is I want to hear it first, but as soon as I have an idea of just how clear it is, I'm going to replace that speaker with a 4 ohm load. It's 2 8 ohm resistors in parallel, so we don't have to listen to the noise. And then I've also got the analog meter measuring millivolts AC, and that is going to be measuring across the load so we can actually see what amplitude we're getting on there. Right, the oscillator has been properly aligned. That means alignment points 1 and 2. We'll now go to the intermediate, which is 3, 4. Put the volume a bit down and tune it to 160. It's back to 160. Now we're going to do alignment point 3, which is that little tuning condenser there. There's my peak. While I'm at it, I'm at 160. I'm going to do the front end one as well, which is 0.6. I'm not seeing much change. Actually, that's because I'm not using the external antenna. Got to do that afterwards. What I can do is I can do 8, and 8 is that guy over there for a maximum. Now I'm not sure how this is going to work because I'm touching it. Oh, I see, it is pretty sensitive. I'm just shifting the position. Well, that seems to be it. We've done 8. Okay, we'll do the same at the top end now. At 370. That's up at 370, and at 370 we need to do 4. I'm not even sure that I'm getting in there, and I'm not going to press it. So I'm leaving that for now, and 7. And 7 is that guy down there. That's also got to do with the external antenna. But I can do 9, which is the first one up top there. Not getting anything. No change. Well, that's going to stay like that. I'm just going to change this now to, I need to do that one at 240. I set it to 240. This is for that intermediate. Tune it to 240. And I need to adjust this guy. That seems to be a peak. And we're done. What I'm going to do now is I'm going to take that loop away. There's the one test that's we're using the external antenna, the one that says Vorkreis. And I think we had no response with the loop. So I've connected the signal not to the external antenna, but just to the plastic next to it. So we get a loose coupling there. I'll select external antenna at the top over there. And I've now set that to 160. And we need it to adjust 6 for a maximum, which is that guy there. Let's see if we can get any change. I'll just put the volume up a bit. Oh yeah, okay. There we go. Now I'll move that up to 370. And tune it up to 370. And we need to adjust 7, which is that guy down there. Yep. Okay, there's our peak. We changed it just a little bit. And that looks like it is done. So what have we got here? I've set it to 160 kilohertz. Give it some volume. there's my peak, and just doing away with some parallax, it's exactly at 160. If I go to 370, you can see that little white notch on there. Again, making sure there's no parallax. This thing is spot on. Bloody hell, nice. Let's try 250. Some real bad noise over here. Just off. But that is bloody well, that's fine. That is fine. So we have adjusted the, we have RF aligned the long wave, and we've actually done it for the ferrite antenna as well, which I wasn't sure I was going to be able to do. Now, there's no need, I think, to go through this whole thing again for all the other bands. I'm going to do the medium wave, shortwave 1 and shortwave 2. And when I finish that, we'll come and test it, and then we'll get on to that guy. All right, let me get on with it. All right, time for a test. This is on long wave, 160 kilohertz. Spot on. Long wave, 370 kilohertz. Yep, it's there. Medium wave, 1425 is the top one. Or is it 1450? $1,450. Select medium wave. There we go, spot on. The bottom end is 560. Over there. I'm trying to keep parallax out of this. Spot on. Shortwave 1 is 1.7 at the bottom. 1.7 megahertz. That's shortwave 1. Slap on there. The top is 3.4. 3.4 megahertz. That's that guy over there. Spot on. Shortwave 2, the top is 5 megahertz, which is here. There we go, 5, and the bottom is 3.4. So let's go down to the bottom. Bloody hell. Well, that, my friends, is probably the closest we're ever going to get. So all these bands have now been aligned in terms of the antenna tuning, in terms of intermediate and oscillator tuning. These things are as close to accurate as I think they're ever going to be. Maybe even as close as they've ever been. Now the next challenge, is this little bugger over here. And this thing's been going on for too long. I'm going to break the video here. I'll do this one in a separate video. I just need some time to figure out how to open this up. I haven't opened the backup yet. I want to make sure I don't mess it up. So what I'm going to do is I'm going to sign off for now and get back to you very, very soon, because I really am anxious to align this guy. This is actually what my biggest challenge is going to be, and it's the one I'm looking most forward to. So I want to thank you for watching. I'm sorry this has been a bit dragged out, but I guess it has to be. If you want to do this accurately, there's a lot of detail. I hope I explained it correctly, and that the displaying of the videos is actually in a logical order, because this does involve quite a bit of filming of using different cameras and all that jazz. So it gets a bit complex, but I do hope that this thing proves useful to anybody who wants to align one of these. And maybe you don't have to go through so much hassle trying to figure out for yourself. Well, once again, hope you've enjoyed that. If you've enjoyed that, please click like, and then you can share the video on social media, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. The links are at the end of the video and in the description below. So thanks for watching. Bye for now and stay safe.